Hello, I'm Mathieu Gestin, PhD student at the INRIA of Rennes, and I will present our work on anonymous credentials that we did conjointly with Daniel Bosk, Davide Frey, and Guillaume Piolle. First, I will recall what anonymous credentials are, then I will present why anonymous credentials are not always so anonymous, and finally, I will present our solution to circumvent this problem. So here is Alice. Alice goes to a bar, and she wants a beer in this bar, but the bartender needs to verify that she is over 18. So previously, because Alice is French, Alice will get a credential from the French administration, and because the bartender trusts the French administration, he gathers the public key of the French administration and put it in his trustees database. In the second time, Alice gets her credential from the French administration, so the credential is signed with the secret key of the French administration, and Alice can put this credential in her wallet. Back to the bar, when Alice wants to prove that she is over 18, she can take this credential and she can randomize it. It is to say that she adds some random element to the credential, and now from the bartender point of view, the credential is equivalent to a brand new credential that was just issued by the French administration and that was never used. So Alice gives this credential to the bartender, and the bartender can verify the credential using the public key of the French administration, and because the credential is valid, Alice can get her beer. Now we need to note that one of the goals of anonymous credential is to give only one information, which is the information stated by the credential, and no more information. But we'll see by studying what does the bartender learn that it is not always the case. So first, the bartender learns that the user is over 18 because it is what is stated by the credential. He also learned that the user is a woman because Alice went to the bar, so he saw Alice at the bar and he knows it is a woman. But furthermore, because to verify the credential of Alice, the bartender used the public key of the French administration, the bartender knows that the user is French. So here we have one information that Alice didn't intend to reveal to the bartender, but that the bartender learn anyway. Furthermore, Alice didn't go alone to the bar. She went with her friends Charlie and Bob, who are French, and Dewey, Emily, and Fanny, who are Italian. So just like before, the bartender trusts the Italian administration, so he gathers the public key of the administration and puts it in its trusted database. And just like before, Charlie and Bob get credentials from the French administration, and Dewey, Emily, and Fanny get credentials from the Italian administration. They all put their credential in their wallet, and now, from the bartender point of view, and if we assume that there are only 3 citizens in France, which are Charlie, Bob, and Alice, and only 3 citizens in Italy, which are Dewey, Emily, and Fanny, we have 2 anonymity sets, the set of French citizens that are over 18 and the set of Italian citizens that are over 18. And if we assume that the bartender colludes with the French administration, now the bartender can learn more information about the user. So just like before, he learns that the user is over 18, it's French and a girl, but because the French administration gives him information about people that are over 18 in France, he knows that the user is either Alice, Bob, or Charlie. And because in this set there is only one girl, the bartender learns that the user is Alice. And if he asks information to the French administration about Alice, he will get a lot of information, all the information the French administration knows about Alice. This is not what we want with anonymous credentials. With anonymous credentials, we want the anonymity sets to be as large as possible. But with classical anonymous credentials, the anonymity sets depends on the issuers of the credentials. In order to have the largest anonymity set as possible, we want the anonymity set to be defined by the issuers trusted by the verifier. And in our case, we want the anonymity set to be all the French or Italian citizens that are over 18, or at least because the bartender knows that Alice is a girl, all the girls that are either French or Italian and that are over 18. To do so, what we want is to hide the issuer of a given credential during the verification phase, but we also want the verifier to be sure that a credential that he accepts comes from one of the issuers he trusts. So how do we do it? We take a classical anonymous credential scheme and we build a hidden issuer anonymous credential scheme by using a new cryptographic protocol that we call an aggregator and that I will present now. So the verifier, in our case the bartender, takes all the public keys he trusts and he generates an aggregator, which is the cylinder here, and a secret verification key, which is this key here. Afterward, the user, Alice in our case, will gather the aggregator of the verifier, but before using it, she needs to verify the integrity of the aggregator. It is to say that the verifier will state things about the keys that are aggregated in the aggregator, but the user needs to verify the statement. The verifier could be lying. For example, in our example, if the verifier states that there is the French and the Italian administration public keys in the aggregator, but in fact he only put the French administration public key, then when Alice proves something about her credential, she falls back in the classical anonymous credential scheme, and she loses all the anonymity properties that she can get with the hidden issuer anonymous credential scheme. So she verifies the integrity of the aggregator using this integrity verification function, which outputs 1 if and only if the keys that are stated by the verifier to be in the aggregator are indeed in the aggregator. When this function, when Alice knows that the aggregator is valid, she can use this with create function to randomize the public key of the issuer of her credential, and she uses the aggregator to produce a proof that this randomized key belongs to the set of public keys the verifier trusts. And finally, the verifier will get the proof and the randomized key, and he will be able to verify using the secret verification key that the randomized key belongs indeed to the set of public keys it trusts. So an aggregator has two main properties. First, the collision freedom property, which states that if this verification function outputs 1, then the verifier is sure that the randomized key belongs to the set of public keys it trusts, and the element indistinguishability property, which states that even though the verifier knows that the randomized key belongs to the set of public keys it trusts, he cannot learn which key was used to produce this randomized key. So now, how do we use an aggregator in a hidden issuer anonymous credential scheme? First, the bartender needs to produce the aggregator. So he produces the aggregator when he adds keys to its trustees database. And when Alice wants to prove that she's over 18, she will gather the bartender's aggregator. She will verify its integrity. And afterwards, she will randomize the public key of the French administration. She will produce a proof using the verifier's aggregator that this randomized public key belongs to the set of public keys the bartender trusts. And finally, she will randomize her credential. And now, when the verifier wants to verify this credential, he no longer needs to use the public key of the French administration, but he will need to use the randomized key. And this randomized key cannot link to the French or to the Italian administration public keys. Now, we have two possible anonymity sets. Because the bartender doesn't know if the credential was issued either by the French or the Italian administration, and if the bartender doesn't know that Alice is a girl, then the anonymity set is the set of all French and Italian citizens that are over 18, and if the bartender knows that Alice is a girl, then the anonymity set is the set of all girls that are over 18 and that are either French or Italian. On the efficiency side now, we'll compare our scheme to the Poincheval-Sanders anonymous credential scheme, which is a classical anonymous credential scheme, and to the issuer hidden attribute-based credential scheme, which is a scheme which was produced recently and which has the same motivation as our scheme. So all the numbers you can see here as a number of group operations required to run each function. On the issuer side first, we can see that our scheme is longer to run than IHABC scheme and than the Piolle-Sanders scheme, but these functions are not run very often, and their absolute running time is short. On the user side now, the integrity verification function, we can see that the numbers are underlined here. It is to notice that this function is linear in function of the number of issuers trusted by the verifier. Here you have the number for 100 issuers, and we can see that our scheme performs 3 times better than IHABC scheme. To randomize the credential now, we can see that the known issuer setup, so the Piolle-Sanders scheme, is more efficient than the hidden issuer setup. But we can see that both our scheme and IHABC scheme perform with the same efficiency when it comes to the randomization of a credential. And finally, on the verifier side, we can see that the verifier setup function is also linear in function of the number of trusted issuers. And but we can see that our scheme performs 2 times better than IHABC scheme, and just like to randomize a credential, the verification of a randomized credential is longer to run with a hidden issuer setup than with a known issuer setup, but both our scheme and IHABC scheme perform more or less as efficiently in this case. So to conclude, I presented why anonymous credentials are not always anonymous. I presented a collision-free element indistinguishable cryptographic protocol that we call an aggregator, and I presented how to use this aggregator to build a hidden issuer anonymous credential scheme. Thank you for your attention, and if you have any question, I will answer them now.